In this video, I will finally conclude this lecture. So these are some certain wireless communication technologies. In this lecture, I will just brief you about the wireless communication, the type of wireless communication, many of the things. So I would definitely repeat many of these things we have already discussed before as well. So this is the representative figure representing different technologies, the wireless communication technologies. So the different signals means the choice of frequency is very important for wireless communication because the medium is wireless, and based on even the usage of the frequency, you can differentiate the wireless communication. The radio frequency transmission communication, infrared communication, microwave communication, light wave transmission or communication. So which frequency is going to be used already we have discussed, because if you will change the wavelength of your signal, definitely the way your signal would behave, for the level of attenuation it can bear, the distance it could traverse. So uh, all that thing depends on the frequency and wavelength of the signal. All these things I'm not going to repeat. Just in a moment, I would once again brush it up for you so that later on we will start the standards, the mobile standard, the mobile communication standard. It would be easier for you to relate with the frequency usage there. So the radio frequency transmission, if you would see, so just imagine a frequency spectrum starting from the radio frequency and going till uh, the higher frequency. So from lower frequencies, you will start and going towards the high frequency, or in reverse, if you will see, uh, from higher wavelength, you will start and you would end up with the lowest wavelength. So radio frequency falls in that range where the wavelength is more, so that they can penetrate the buildings because the wavelength is more. But the problem with the radio frequency, the radio communication, is that it can't carry uh, more data along with it. That is so. That's the dichotomy associated with the radio communication. The radio. So and one more drawback with the higher wavelength is more prone to attenuation. Though it can traverse a longer distance, but it is more prone uh, to attenuation if we are using the amplitude modulation for that purpose. Then for a smaller distance, for a shorter distance, so there's a wireless communication where you can use the infrared light, like for your remote control, for TV remote control and AC remote control. There we use the infrared communication. So infrared communication, it falls in between uh, the visible light and those microwaves, I guess. Then comes the microwaves. So if we have to use a signal for point-to-point communication, these are not going to penetrate building. These microwaves are not going to penetrate building, but they can carry a lot of data. So they are mostly used in point-to-point communication. So you require more infrastructure for exploiting this wavelength, this frequency. Microwave transmission, it's not going to pass through the building, and bad weather affect the signals more. So these are more prone to attenuation, more prone to distortion. Then comes the optical waves, or simply the light waves. we generally use the light waves for optical transmission in optical fibers. These also cannot penetrate through the rain. Uh, One general rule is, so if you have a frequency more, that means that the behavior of that would be more like light waves. So if you have to understand the impact of frequency on the behavior of signal propagation, so in order to practically understand, the general rule is that more the frequency, it will start behaving more like a visible light. And we know, because practically we observe the visible light, so we can relate with the frequency with visible light more. So if you have to compare anything with respect to its behavior, then try to analyze it with respect to the visible light, that where it falls, whether its wavelength is less than the visible light wavelength, it's more in terms of frequency, what is the scenario. Now, based on the distance of communication, the range of data, and the type of the device being used, we can further categorize. So the previous categorization is based on which kind of frequency, which kind of wave itself we are using for the communication. So you could have the wireless communication based on microwave, infrared, light wave, and one more, radio communication. So based on the requirement, based on the frequency dependent behavior, you can figure out which communication uh, we want to rely on and would use. Further, based on the range of the data and the distance of the communication and the type of the type of the devices being used there, you could have a further categorization in these broader categories. Radio and television broadcasting, as we all know, generally initially it started with broadcasting. That means from one to all. So there is a base station somewhere, the broadcasting station, which would use certain radio frequencies, and over that it would broadcast. They generally use like in FM and frequency modulation, they use the frequency modulation, and in frequency modulation also they use the concept of space division, because the Delhi FM use the same frequencies being allocated to them as the Bangalore uh, FM. They are operating on the same frequencies, so but they are far distance apart, so can use the same frequencies. So based on what kind of modulation and multiplexing technology you are used, you could have further divisions as well. Then the radar communication, satellite communication, as the name are self-explanatory. I'm not explaining too much, because in the next lecture onwards, we'll focus on cellular communication. Today, we have discussed about the cellular concept in detail, and in the next lectures onward, I will focus on the cellular communication standards. Then global positioning system, Wi-Fi, Bluetooth, radio, RFID, radio frequency identification. So the next lecture onwards, I will focus on cellular communication, starting from the analog communication, AMPS, and then digital communication, starting from the second generation onwards till fifth generation. Hope we would be able to complete this in the stipulated time period, because there are a lot many things to discuss. Somehow I will manage it. And then in the next module, our aim would be on Wi-Fi, wireless LAN. And there we will discuss Wi-Fi. So out of all these wireless communication, wireless technologies, our focus would only be on the cellular communication and wireless LAN, that is Wi-Fi. And finally, on ad hoc network also we will see. So we'll see you in the next lecture on Saturday. If you have any query, anything before Saturday, you can mail me, you can message me, so that in the coming lecture or even before commencing the lecture, I could address that thing either through video or through responding individually to your queries. Okay, thank you.